Hello my dear friends, welcome back to our YouTube channel ADC Max. You see, we have seen the series of lectures on the Z transforms. We know the value of Z transform of n, that is Z by Z minus 1 whole square. But what about Z transform of n square? What's Z transform of n to a power n? We don't know. Yeah, we can find these values once we will prove this property. So this property says that the Z transform of n into f of n, the product of the polynomial function n into f of n is equal to minus z into d by dz of f of z. What's f of z? Is the Z transform of f of n. What's Z transform of f of n? Sigma n equal to 0 to infinity f of n is z power minus n. So once we proved this result, then we can easily find out Z transform of n squared, Z transform of n power 3, Z transform of n by a power n, etc. etc. It's very easy for us. So shall we go for this proof? So in the right hand side, because I have the right hand side is minus z d by dz of f of z. So what I want to feel that, can you start from right hand side, but the right hand side I need f of z. So what's f of z? As we know that the f of z is nothing but the z transform of f of n, isn't it? This is a given data. It's a given data. So by the definition is nothing but sigma n is equal to 0 to infinity f of n into z to the power minus n. So this is the definition, it's already there. But in the right hand side I have d by dz of f of z. So that I differentiate. So now differentiate with respect to z on both sides. With respect to z on both sides. What we will get? So once we differentiate with respect to z on both the sides, we will get the left hand side is d by dz of f of z. Right? The right hand side d by dz of sigma n is equal to 0 to infinity f of n into z to the power minus n. So I am going to differentiate z only. So this is the summation. So this comes outside, sigma n equal to 0 to infinity f of n, and this operator into the term only for the z to the power minus n. So what is differentiation of z to the power minus n? So we get sigma n equal to 0 to infinity f of n is equal to minus n into z power minus n minus 1. Isn't it? Right? Now this can be done as minus taken outside. Sigma n is equal to 0 to infinity. Combine this n along with the f of n. So n into f of n. And this z power minus n minus 1 can be done as z power minus n into by z. So this z power minus n by z. Is right, sir? Now this z can be multiplied to the next side. The left hand side I have d by dz of f of z, and our ultimate aim is to get the z transform of n into f of n. Now this is after taking 1 by z outside. This becomes minus 1 by z. Sigma n is equal to 0 to infinity n into f of n into z to the power minus n. Now this is, see that this is exactly looks like the z transform of n into f of n, isn't it? Is right? In the place of input is n f of n, the format is z power minus n. Yeah, z power minus n equal to 0 to infinity, 0 to infinity. So this minus 1 by z multiplied to the next side, what we'll get? We'll get it is minus this z, the cross multiplication we get z into d by dz of f of z. So I think so I got this answer. Right? So this is the very interesting property, because once we got this result, we can easily find out, as we said, n squared, n into n minus 1, n plus 1 to n plus 2, or n into a power n, whatever so. So we can easily find out the result. We can get the answer for these things once if we know this property. Now, shall I start with the what is z of n squared, what is z of n into a power n by using the same result. Let us see. I am going to use the same result to determine the z of n squared, z of n into a power n, etc. etc. So let us see what's z transform of n squared. So how to get the z transform of n squared? This can be as n into f of n, right? Now in this case, this is considered as f of n. Now this is looks like this formula, right? So this is equal to minus z into d by dz of z transform of n, because this is f of n. So what is z transform of f of n? F of z. So what is z transform of n? Once if we know this result is well and good. So minus z into d by dz of z by z minus 1 to the whole square. So let us differentiate this with respect to z. We will get the answer. So by using the u by v formula, z minus 1 whole square to the whole square, and v squared v into u dash minus u into v dash. So this is looks like the u by v formula. This looks like u by v formula. V squared. What's the differentiation of the u by v formula? U by v formula is v squared v u dash minus u v dash. So this is my v, this is my u dash, this is my u, this is my v dash. Is right? Right? So this is the v squared. So this is the formula. Now after differentiation, can we simplify this? We get the z of n squared value. So what happened? So minus z into. Can we take z minus 1 common from the numerator? So z minus 1. What's the balance here? We have one more z minus 1. Here we have minus 2 z1. Is right? Because of minus 2 z into z. 2 into z. So minus 2 z. I have taken this z minus 1 outside. Divide by z minus 1 whole power 4. After that I can cancel 1 z minus 1. So we will get the answer. Z transform of n square is equal to. What about this one? Minus z into the numerator, z minus 2z. What is z minus 2z? Minus z. So this minus 1 minus z by z minus 1 whole power 3. By taking minus sign common outside, this will give simply plus z into z plus 1 by z minus 1 whole power 3, and the region of validity is mod z greater than 1. So this is the z transform of n squared. Z transform of n squared. Right? So what about z transform of n into a power n? The same concept when you use the z transform of a power n. What's z transform of a power n? What's z transform of a power n? Tell me. Z transform of a power n is nothing but z by z minus a if the modulus of z is greater than modulus of e. So the same idea, when we apply this, we'll get the answer. So what is z transform of n squared? So once we know the z transform of n squared, let us go for it. Z transform of n squared is equal to z into z plus 1 by z minus 1 whole power 3. Right? Now, what about z transform of n into a power n? N into a to the power n. So here the f of n is a power n. So what's z transform of a to the power n? So what's z transform of a to the power n? So by using the property, once again, by using this property, minus z into d by dz of z power n. So this is equal to minus z by d by dz of. What is the transform of a power n? I think so z transform of a power n is z by z minus a. So now differentiate this by using the same u by v formula. So minus z by z minus a to the whole square, z minus a into 1 plus u by v formula. U by v formula, v square v u dash minus u v dash. That's right. So I think so z minus z will cancel. So minus a, minus of minus plus a. So the answer is z transform of n into a to the power n is equal to minus of minus becomes plus. So a z by z minus a to the whole square. And if the region of validity is mod z greater than mod a. So the answer is very simple. So once if we know this result, we can generate as many results what we require. So this is the n into a power n. Got it? I hope you may understand this concept. And with the help of z of n into f of n, we can get even some more ideas. What is that? Tell me what's z transform of n into n minus 1? Yeah, the same idea. Z transform of n into n is n squared minus n. By using the linear property, z transform of n squared minus z transform of n. So now if you know the z transform of n squared is nothing but z into z plus 1 by z minus 1 whole power 3 minus z transform of n is z by z minus 1 whole square. That's it. Let us take the z minus 1 as LCM. Let us simplify that. We get the answer. So z into z plus 1 by, I think so, z minus 1 whole power 3 is LCM. So z squared plus z minus of z into z minus 1. So minus z into z minus 1 minus of minus z is minus z squared. Then we get it is z squared plus z minus z squared plus z by z minus 1 whole power 3. Z squared get cancelled. So the answer is 2z by z minus 1 whole power 3. This is the z transform of n into n minus 1. N into n minus 1. So in the same way we can do as much as possible. As much as possible. When we go for the one more result, that is n plus 1 into n plus 2. What happened? n plus 1 into n plus 2, yeah, the same idea. Z transform of n squared plus 3n plus 2. Yeah, by using the linear property, we can go for it. Z transform of n squared plus 3 times Z transform of n plus 2 times Z transform of 1. So Z transform of n square is Z into Z plus 1 by Z minus 1 to power 3 plus 3 times Z transform of n is Z by Z minus 1 whole square. What is Z transform of 1? Z by Z minus 1. So if you know these results, then I'm good. Let us simplify this, you will get the answer. That's it. So this is the application or the use of this property. Z transform of n into f of n, the product of the f of n along with the polynomial function, it is minus z into d by dz of f of z. So with this we can generate so many new results with the help of the single property. Thank you. Thank you so much for watching our YouTube channel. Please kindly stay on this video channel. There is this YouTube channel ADC Max, and also recommend to your friends so that they also got benefited. Thank you so much. Bye. Take care.